What are you doing?
Can you hear me? Wait, I can't see you. You can?
Oh.
Or you can't?
Why is it still beeping at me?
I can't see you either.
I can hear you.
Okay, good. Should we turn off our video?
Hold on.
Like, and maybe just do the mic? Maybe that will be better.
Try to refresh that. Did that work?
Okay. Yeah, can you hear me?
Whew, that worked. Okay. Can you still hear me? Yep. Okay.
Yes. Wait, we're lagging. Ah!
Okay. Whew. Oh no! Is it working now?
Yes, I think so.
How about now? Okay. Woo!
I think. Am I lagging?
So.
Wait, I cannot hear you.
Hopefully we can get through this. Think so. Am I lagging?
A little.
Oh, I can hear you like crystal clear.
You can?
Maybe we should do some sign language and then.
Hold on. I'm going to try something.
This is so funny. I can.
Okay, can you hear me?
Yeah.
Okay, am I lagging?
No.
Okay, good. Yay!
Whew. That was,
oh,
that was stressful.
Okay.
I think it's my computer. I think I need to. It's only got 2 RAMs on it, and I think it's starting to get flustered.
Mine like can't multitask very well either. I just actually disconnected it from the internet and then reconnected it, and I feel like it's better. So I don't know.
Okay, I'm concerned because I don't know if I can open up Google Maps and do what it wants us to do without. Because I think that's why my computer. Yeah, I think that's why it crashed the first time, was because I opened up Google Earth and then it was like, oh, well, now you can't talk to anybody.
Oh, maybe I can probably just do it.
Okay.
And then we can just talk about it.
Yeah,
Okay.
that might work.
That is. Wait a minute. Okay, so we have to look up
Mount Reiner.
Okay, you know what? Maybe I can. Oh. This is so much.
Yeah, I was looking. It's a lot of questions.
I know.
This is what we get for procrastinating.
I'm going to try to share my screen with you. But first, I have to find the actual Mount Rainier because for some reason it's. Let's see if this is.
Yeah, yeah.
Okay, hold on. Not. Okay. Let's see if this works. Yay! Whoa, this is cool. Okay, I'm gonna share my screen with you. How do I do that? I need to turn it on. Then screen share. Okay, let me know if you can see it.
I think it's, oh, there it goes. Okay, it was loading.
Okay. How do I zoom out? Zoom out. Here's the mountain.
Woohoo!
Okay. So we need to use the line tool, draw one transects from east to west, another from north to south.
Lines following the.
Look at the. Oh dear. How do I know?
No, I wonder if it's these little like river. Yeah, like there's green and then there's like that little road looking thing in between them. I mean, I don't know. I could be just making up words.
Oh. Oh wait. Oh, we are facing north right now. So I just need to draw a line down the middle, I guess.
So you
Where's
come
the
off.
line tool? Line. Add a. What?
So I think you start at the south base part of it, and then you move all the way to the north base.
Okay. Can't figure out which says the line tool. Add a path.
Yeah, I think it's at a path.
Okay.
Yeah, where you were before that third one. And then you could probably.
I don't think that's what we want.
Yeah, that's what you want.
It is?
I've done, yeah, because I did that in my lab. Into like the map part. You'll point at one spot and then you'll point at the other spot and it'll draw a line for you.
I don't know if it's.
So before you make the path, like before you write in the path and everything, you can make your line first.
So I click on add path.
And then on the map itself, before you do anything else in there, you make the path. Yeah. And then, yep.
And then click up here. Like that?
Yep. Just like that. And then you can change the name to north to south.
South.
What that one is.
And then do another one.
Yeah.
To west. East. To west. To west. Okay. Look at the elevation profile for the EW transect. How do I do that?
So then what you're gonna do, yeah, so right click on the east to west. Go to Yep.
Ooh.
At the bottom, the bottom of your screen, you have like the little elevation thing, and you can drag your thing across it. Yep, and that arrow will show you where you're at.
That's so cool. Interesting.
So, based on what you observe, predict what kind of volcano you would expect this to be. Oh crap, do I remember anything about volcanoes?
I'm pretty sure it's the hold on, I think I know what it is, but I can't remember the name.
Is that in chapter 5? Because I haven't even gotten 5 yet.
Yeah, I think it's in chapter 5. I actually just read it, but I did not retain it very well.
Well, there was just so much to read this time. I was like overwhelmed.
Okay, I think it's a composite cone volcano. Yeah. Because actually, I think it talked about Mount Rainier in the reading. Google Docs send to you?
Does what?
Did you get the Google Doc?
It stopped looking when my computer.
Oh, it's okay.
Probably did. Sorry, I probably did. I just need to get it open.
Okay. Composite cone. Yeah. Composite cone. Do a screen capture of the elevation profile of the EW transect and use that to create an illustration that resembles the kind of architecture you would expect for this kind of volcano. Be sure to annotate / label your illustration. Great. Okay. I'm going to screenshot this.
Okay.
I think that. Yes. Okay. I don't know how we're gonna
label it though.
Unless there's like labels in here. Probably not.
No. What kind of architecture?
Well,
what does it mean by resemble that kind of architecture? Is it talking like volcano architecture or like?
I think so.
Man-made architecture.
Yeah, I think like what you would expect the volcano to look like the composite cone, like what are the basic like structure
inside of it?
Yeah, or something like that. Okay, we'll come back to that. Compare the elevation profiles for both transects created above. Which side of the mountain has the lowest elevation?
Oops.
So which side has the lowest? Okay, so the lowest on this side is.
So to get rid of that tour guide, I think you can go up to view. And yeah.
Okay.
Ooh, there we go.
That looks better. So this side's 5,219, 5,378. So we want to see the other one. And 4,318. Okay, so it's the south end.
Yeah, that's what it looks like.
1,318 is the lowest. So okay, let's do south end, 4,318. Oops. Okay. What consequences could possibly result on the side with the lowest elevation? As a result of that topography, take into consideration what type of volcano this is and what potential hazards exist. Okay, I'm going to try to pull up the book really quick. Let's see.
On the side. Well, can't on the lowest side, couldn't you have like a lot of lava spill within that section right there? And like. Maybe I'm just
Yeah.
saying.
Yeah, that's what I was thinking. Or like, because if it's steeper, obviously, because it's steeper, right? Because it
Yeah,
has, so I guess more lava flow would come down that side.
probably more lava
I
flow.
think.
And I also get the feeling too that if it's lower in elevation, because when volcanoes form, you have that the anosphere
Uh-huh.
um, pools up. So I'm wondering if in those lower sections, if you could have like, I don't know, a mini volcano maybe, or not a mini volcano, but you know what I mean, like a hole of some sort.
Oh, like the yeah, I know what you're saying, because like you're talking about the the magma that's building up, and it's like a lower
Yeah,
elevation, so it's closer to the surface.
yeah. So that probably could cause problems there if with it pooling or something like that.
That's a good one. I wrote that down. So magma pooling in area of elevation. Say growing. Is it the asthenosphere?
Yes.
Okay. Okay, I'm gonna pull this book. We'll see if it actually loads. Because
Yeah.
it says that the composite it also has like, I think composite has the largest explosion, so it has hot ash, it has the lava, it has like all the gases,
Yeah, that would make sense.
lava bombs and stuff, and so it has all of those.
The ash could
Yeah.
be a huge problem too, especially if you have a huge cloud.
Mm-hmm.
Maybe it'll load.
Let's see. Oh, my computer hates multitasking. It's like, please stop. Fucking working so hard. Okay, let's find our volcano. Okay.
I'm thinking of a number.
Okay. Girl. All right. 5 something. Nope. Too far. Okay. Was it? The anatomy?
Probably.
Undercones.
I bet you it's an anatomy.
Yeah. Wait, here it is. Composite volcanoes.
Boom.
Oh, come on. Okay. So they're symmetrical with alternating layers of explosively erupted cinders and ash interbedded with lava flows. Composite cones reflect the viscous nature of the material. Let's see. Gives us anything else? I just want to make sure.
Oh yeah, I don't blame you.
Watch, it's not composite.
You are failures. Dang it.
It is, yay!
See, you're smart.
Stratovolcano. Okay, good. Okay, let's go back to this thing. Okay, so okay, in question 1.1, you predicted the kind of volcano this would be. Based on that answer, what rock types might you find in this area?
Oh. Wouldn't that be... Couldn't you have both the, oh my gosh, words.
I know.
Couldn't you find both the metamorphic rocks and the igneous rocks?
Yes, I think so.
Because, oh goodness, because it's so hot and you have so much pressure there, I feel like you would find metamorphic rocks probably within the mountain itself, but I'm sure they're there. And there's definitely igneous rocks because those are the
volcanic
external
ones,
rocks. Yeah, the
so,
but I feel like if you like,
yeah.
No, go ahead.
I don't know what I was gonna say. Keep going.
You probably would find a lot of like granite type rocks, I feel like.
And
And
those are metamorphic, right? Are they granite? Or
are those igneous?
Oh wait, because granite
so
forms on the inside of the earth, so I think it would be metamorphic because granite isn't like a surface forming rock.
Yeah, so I feel like you'd find the granite rocks. 61. I don't know which rocks are which. You definitely would find sedimentary rocks, not sedimentary, sorry, igneous rocks though, because when they're, especially like when the mountain goes off and like there being all that ash and like the lava coming out, you have like the lava when it cools eventually, and it's got like, because it's a quick cool, it'll have like crystal kind of stuff in it, but I think you'd still have the igneous rocks instead of minerals because it's all melted together.
Right.
I don't know if that made sense, but there it is.
What are, I can't even remember the names of igneous rocks. Wait, is basalt one of them? Or am I thinking of something totally?
You know what? I think basalt does come out of it because
I think it does too.
I feel like you're telling the truth.
Okay. I'll look this up. Cannot remember. Because basalt, not basaltic, basalt. I think basalt is formed by lava.
I think I agree with you on that one.
Oh yeah. Basalt is a dark colored fine grained igneous rock.
So basalt will definitely be one then.
And it forms as extrusive, such as lava flow, but it can form intrusive bodies. Okay, yeah. So, yeah, those are two examples: granite and basalt.
Granite is an igneous rock. I just saw.
Oh, it is?
Yeah. Crazy, right?
What would be? Yeah. I think what a metamorphic rock would be.
Metamorphic rock. No, I don't want those. Marble's a metamorphic rock.
Oh yeah. Yeah, maybe there is marble.
I don't know. Yeah.
I don't know either.
Starting to question if you do get. I feel like metamorphic rocks would be though, like not on the outside, obviously, but I feel like on the inside.
Yeah, because
from all the heat and the pressure.
Yeah, from the heat and pressure, and oh yeah, I think there would definitely be.
Okay.
Just put this as examples. Okay. Cool. Take a close look at the mountain and its surroundings. What other geologic features do you notice in this area? Okay,
Snow.
let's close this.
I guess
Yes.
it's not geologic.
Okay, let's zoom in a little. It's like all these little like lines coming down from the mountain.
I'm wondering if that's from the snow when it melts, if it's creating like streams and stuff.
Yeah, or if it's actually from lava flow.
Yeah, or is it a
Yeah,
lava
or
flow?
water melt or ice melting. Okay, we can write that.
I don't know if it's lava flow. Well, I don't know. I guess it could be lava flow. I don't really know how lava flow like moves. Like if it's in a nice line or if it just kind of like pools, you know? Like I know it pools, but I don't know like how big the lines would be, if that makes sense.
Type. Oh, I'm just laughing at this, how slow it is. Coming down from the mountain that may be streams, snow melts, etc. Let's see what else. So, it all looks kind of the same.
I know.
There's like hints.
I'm learning. I don't know. There's definitely a lot of hills and valleys though. Like if you look at it, it looks like the elevation, it's very hilly. Like it's not just, oh, here's a mountain. It's like here's hills leading up to the mountain.
Right.
It's so dark. I need to turn the brightness up.
With lots. Valleys up to okay. Let's come over here and see if there's anything else. The city.
Yeah. Yeah, that's really all I see. It's got a lot of grass, it looks like. You know, it's not desert looking, so stuff definitely grows there.
There's a lot of like sharp peaks. Like look at all of these. Like these are really sharp.
Yeah. Maybe
like,
they must be like mini mountain kind of thing.
Yeah.
I wonder if that has anything to do like with as like the tectonic plates are moving or something. Like you've got these different areas, or if it's just it like the mountain obviously must have like the big hotspot, I think is what they're called. But I'm wondering if these are like used to be hotspots or had some kind of something that pushed them up like that or something.
Yeah, or if it's like part of the hotspot or influenced by the hotspot.
Yeah. Because those are actually look like pretty big peaks. Like it doesn't look like just you know, small things.
Oh no. My charger, hold on.
No, you're good.
Okay, I'm back. Sorry.
Good.
Hit sharp peaks, possibly influenced by what? Okay. Backing out a ways from Mount Rainier, answer the following. Is this volcano close to any tectonic plate boundaries? How far away is it? What kind of tectonic boundary is it? What direction do you think it's moving relative to North America? Do you think there's any relationship between the tectonic setting and the occurrence of Mount Rainier? You do explain relationship. Okay.
I'm wondering if you have a button. I know I have a button that adds tectonic plates. Don't know. I just tried to move your computer with my mouse. That's so funny.
So I know it is on a tectonic plate boundary. So you have like the Juan, what's it called? San Juan something. So there's like one right along here. And so like the plate's going under this like ridge, and then it's creating all these along this whole coast.
Yeah, because that's pushing. It's pressing up against it.
Mm-hmm. How far away is it? I mean, it's pretty close.
So what you could do for that is you draw another line. Wait, is it a line? Your options up at the top. I think. Yeah, I think if you draw like another line like you did like with the north and the south, you can see the distance between your two spots.
Oh, here's not here, and then oh shoot, how do I hold on. Cancel. Okay.
Yep, 26.825 probably kilometers or kilometers. Kilometers. Yeah. You can't just knock on my door and come in. Rude. Oh no, that's
how do you see the distance?
And then go to right click again.
On this.
On the distance, yeah.
Profile.
And then do the show elevation.
Total range 200 miles.
Yeah, come in. I'm gonna hurt you.
Is that right? Yeah.
Boom. So it's approximately.
Yeah. We don't know exactly. I need to find out what that. Hold on, let's find out what that name is.
My goodness, my throat. Did I lose you?
Sorry, no.
Okay, good.
Juan de Fuca plate. Is that what it is?
I don't know. Is it the one? I thought it was up against the Pacific plate, and I thought one was higher, like up against Alaska. I could be wrong.
Yeah, let's see. Okay. Pacific plate. All right, I'm gonna close. Which one's Juan de Fuca plate? It doesn't tell me.
To look up tectonic plates on a Google map. Not a Google map, on images.
Oh, you can?
Yeah, just type in and type in tectonic plates. Yeah, that works. Yeah. And then go to images. Wish we had our other partner here helping us.
I know.
Well,
I don't know what happened to that guy, but
he hasn't done anything. I don't know where he is.
The Pacific plate. Oh, wait a minute.
There's a good one.
Wait. Oh, yeah, because this is the Pacific plate along the west coast.
The one you're thinking of, Juan, I think it does hit like Alaska.
North.
I think so.
Okay.
Stray.
I trust you. I think you're right. Okay. Yes. Approximately 200 miles. Maybe. We'll just say more than at least 200 miles. What kind of tectonic boundary is it? What direction do you think is moving relative to North America? So it's moving, so it's parallel.
Isn't it that the one that's rubbing up against us? The transit?
It's well, because it's a okay. So if it's a subduction, so they're coming together, so that's convergent, right?
Yes.
And then because then the one plate is going underneath.
Let me. No, you're not gonna help me, are you? Dang it! You. No, wait. I've got way too many papers all over the place. Okay, so divergent is the one where it's pulling apart. Convergent is the one where it's pushing down and over. And then the transform is the one that's rubbing up against each other. And I know that somewhere along there that they do transform, because that's one of the reasons why California gets so many earthquakes, because they're to each other. But I also noticed when I was looking at the tectonic plates, like the first week I think we were doing this, it looked like on the points where there was places where there's divergent and convergent, you also had transform spots as well. So I don't because at the top, that's why you have that mountain range there, because it's pushing it up. So maybe it is. Maybe I'm wrong.
No, I actually remember seeing like all the convergent, or sorry, the transform. Is that the ones that rub together?
Yeah.
They kind of go like or like diagonal along it. Like there's a bunch of transform along like the convergent one.
Yeah.
So
well, even I would say even like when I was looking at the Mid-Atlantic Ridge, I was surprised to see like how many transform lines there were along it. I was like, oh, I didn't realize that, you had both. Thought it was just one.
I think so if the convergent forms the mountains, then it probably is what influences the volcanoes.
I agree.
Then convergent. Okay, relationship between the tectonic setting and the occurrence of Mount Rainier. Yes.
Oh yeah, totally. Totally. Because those tectonic plates, everywhere that you look, the mountain ranges always has something to do with the tectonic plates and how they're rubbing up against each other.
Mm-hmm.
So I'm pretty sure that huge impact just because it's pushing it.
So I think I remember in the reading, I don't know if this is right, but this is what I remember. So when the plate subducts, water, because it's in the ocean, the water goes down with it.
Yeah.
Which lowers the melting temperature of the magma, which makes it rise.
That's
more.
right. I remember watching that video on it.
Yeah, and that's what is, I think, creating the volcanoes along there is because of that subducting.
Because, yeah, the water's going into it. Something is going on. I can't tell if it's outside my room or upstairs. Noisiest upstairs neighbors I've ever seen or heard.
Hold on. Oh, why is it so slow? Oh.
When? Oh, yep, that's upstairs.
Okay.
All right, give me 1 second. I'll be right back.
Okay.
They're getting on my nerves. All right, sorry about that.
That's okay.
Whew, where are we at?
For number 4.
Are there any other noticeable volcanoes in the area within a few hundred miles? Oh, man.
Let's see. I know there's more. Let's see. Oh, Rainier's right here. There you go, Mount St. Helens crater. Let's see what else.
In 100 miles. I don't even know what like a 100-mile radius is.
I know. Okay, this one's Crater Lake National Park. That was in the by volcano. Mount Shasta, that's also from a volcano. A volcano.
I'm sure they're all up around there just because of how the tectonic plates work.
So there is Crater Lake and Mount Shasta.
Tell that they have the same pointy peaks and
yeah, Mount Shasta. I think they all have this same well, the only thing about Crater Lake is that so it was a volcano and then it collapsed. And so it made the crater like in the ground and then it filled with water, which turned into a lake. But then other little, because there's still magma underneath where like the volcano was before, the magma came up and made this little like volcano island in the middle of the crater that's called like Wizard Island or something.
That's so funny.
Yeah, so there's like this little volcano peak like in the middle of this crater, which is really cool. Crater Lake. Good night. Crater Lake is collapsed volcano. But the island was created from the Earth's crust. I think Mount Shasta is really similar to Mount Rainier. Let's see. Okay. Is that it? Woo!
And then there was that question like 1 point something or other that we.
Oh yeah.
What?
Okay, so we have to label. We have to label it. So I don't even know how we're gonna do that.
Oh my goodness.
Like copy, oh, you know what? I have an idea. This screenshot. And then I can copy it in this document maybe. And then we can just like type next to it. Okay, let's see here. Oh, oh wait. Screenshots, here we go. Okay.
Okay, I'm so sorry.
It's okay.
Oh, it's funny. because I heard him talk about like calling the police, and I was like, wait, you can't call me until a certain time. But then I couldn't find her because she was hiding from me. Okay. So I think
Okay,
I'm so tired.
Okay, so here's the image, but
You could probably take a better one when the tour guide thing's not in the way.
Oh, that's true.
Because I think it said to use the elevation thing to
Okay, let's do another one.
label it.
Okay, so let's go back. Ooh.
Wait, yo.
It shows airplanes. I was like, it shows airplanes flying?
That'd be kind of cool.
That would be cool. What? This elevation part up, right?
Yes.
Get rid of this box.
But is that the right one? Pull up the east and west or north or south one.
Okay, oh. Elevation profile. Here you go. More so we can see of it. Okay. And out of this. Okay. Hurry up. Okay. Okay. Let's this. Then make it bigger. Okay.
Maybe, I don't know.
Let's see. Under tools. Oh, format. No, it's not. Insert. You might have to do, you can do comments on the side here. This
Yeah,
little
that's what
comment box, and then just like be really descriptive of it or something.
that would work. I am not 100% sure, like, architect of a volcano. I know that you have like in the asthenosphere, and the asthenosphere has that little bump in it. I know that there's like a main chute that goes up to the top, and then there's also like ones that a lot of times will come off onto the sides.
Mm.
But I don't know what any of those are called or where they are. Well, obviously the main shoot would be the middle, but yeah, that's about all I know.
Oh, come on. Why is this so slow? Oh my goodness. It's freezing on me. Like, please.
It's like, and I'm done. You blew your chance.
There's a picture in there. That's why it's so slow.
That'll do it.
No, come back. Oh my gosh. Driving me nuts. I'm gonna go back in here and not do a comment. We're just gonna write it below. Okay. Okay. Do you have is the book online for you, or do you have the actual textbook?
Online for me.
Do you want to pull it up and go back to that composite volcano section
Yeah.
that I was looking at before? Because I would pull it up on my computer. It will probably take 10 years. Because it said like, okay, so I know it has like a cone shape at the top, kind of.
Yeah.
Um,
Let's see.
and it's generally pretty symmetrical, like on all sides. Shape.
Textbook. There. Chapter 5. Listen to my fingers. Composites, volcanoes. Did I? Oh, maybe I did. Nope. Okay. Great if there was just a picture, but that'd be too easy. So they have composite cones are large, they're symmetrical, mostly ash and a bit of lava flow. Silicon rich.
Silicon. Is that going to affect the, like, what rocks are produced in that area?
Yes. Yeah. So, the types of rocks that you have, like all the different ones, when they're silicon rich, I know that there's two different kinds of rocks. There's the silicon rich rocks, and then there's the not silicon rich rocks.
Yeah.
And I think when you have a volcano that is silicon rich, it kind of changes the dynamic of the rock itself, I think. Because silicate rocks are silicon, right, and oxygen put together. Then they can have like different kinds of minerals that are within it. And I think silicon rocks are actually have different, maybe not. Maybe I'm just making up words. I'm trying to remember my lab. Because in my lab, we had to identify all the different rocks and then say like if they were silicate or non-silicate and like what types of each of those they were.
Yeah.
And so I think it definitely has a huge effect if they have a high silicate, just because then you have a certain rock. Because if you didn't have the silicate within that certain mixture, then they'd be a different rock.
Right. Yeah. I wonder if there are
So they have
because
I was wondering that too, because it's got like a lot of snow on it.
Yeah, and snow.
I don't know if it has glaciers. I'm wondering if it's just snow and ice, which I guess is glaciers. But I don't know if it's like
I don't know
like
either.
glaciers. It says that there's a gradual sloping flanks. So I'm sure like the gradual grow to it. There's like, I don't even know. There's not really much saying like. Oh, well, okay. Many composite volcanoes have a secondary vent on their flanks that have produced cinder cones or even larger volcanic structures. You know that.
Oh, I know that these volcanoes do have the cinder cone, so yeah, it could definitely have, I'm gonna add that in there. It could have the what was it called? The like vents, the additional vents?
Yes. Yeah, a secondary vents.
Okay. That produce cinder cones? Or cinders?
Yes. Yep. Yep.
I think that's a good list, don't you?
Yeah, and there's not really much anything else in here that talks about the rest.
Okay.
I don't know.
Yeah, the
We'll go with
shape
that
of it
and call it good. Hopefully that's enough.
yeah. Okay, so I'm gonna find out how to make this public, this Google Doc public, and then we can just copy and paste this link and then the YouTube link in the submission thing.
How do I get the YouTube link?
I'll just email that to you.
Okay. You are awesome. Thank you so much.
You're welcome. No problem. Yeah, I'll let you know when I have changed it to public, the Google Doc. I can't even think.
Okay.
It's the end of the day.
Oh, I know. It's not for bed.
I know, seriously.
All right.
Okay.
Well, we'll try again next week and hopefully it goes better.
Sounds good. We'll start earlier.
There we go. Alrighty.
Okay. See you later.
Bye.
Bye.